Today is the last section of chapter 3 that we're going to cover before the test. So it will be next Friday. The next test will be next Friday. Now this here is going to be the last way. What we're covering today will be the last way that we're going to cover how to solve quadratics. Now some of the ways we've had so far was
happy birthday to Alice, Shelley, and Landon Whitbar. Happy birthday, girls.
Was factoring. Then we had graphing. Then we had the square root method. Our fourth way was completing the squares. And the last way that we had, and that's what we're going over today, is the quadratic equation. This is going to be the last method we will have or go over on how to solve a quadratic formula or quadratic equation. Is what the quadratic equation or quadratic, really not equation. We solve quadratic equations, we're going to use the quadratic formula. Now we went through, and I went through yesterday, kind of finding the quadratic formula, how we would go about getting it. And the quadratic formula itself is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This here is the quadratic formula. And this is what we'll be using for today. We'll be using this today to solve these quadratic equations. And this here is the other way that works every single time. So no matter what the quadratic equation is, it will always give us an answer. It will always give us the solutions to a quadratic equation, no matter what that quadratic equation is. So I would make sure to have this down because this will be useful, this will be helpful, you will need it for the homework. And make sure we have this formula written down. Now the first problem we have is this here. Now there are some steps that we can have, and the first step in using the quadratic equation is get it equal to 0. We need the equation equal to 0. We need everything on the same side. So the only way, or kind of the only exception to get everything on the same side is if we're completing the square. That's the only time we wouldn't have everything on the same side of the equal sign. So is everything on the same side of the equal sign for this here? No, we have the 5 by itself, so we're going to subtract 5 from both sides. Because when we do that, we'll get x squared plus 3x minus 5 is equal to 0. It's equal to 0. Because there are no like terms, so we just move it over and just minus 5. And that gets us done with the first step, step 2. Plug A, B, and C into the formula. So again, when we look at this equation, down the page a little bit, we look at this equation here. Again, we're referencing this back to ax squared plus bx plus c. This is our equation. Now, the formula, or really the equation we're plugging it into, is the quadratic equation, our negative b, plus or minus the square root of b squared minus 4ac all over 2a. And in this here, we're plugging in the values of a, b, and c. Now, the first thing we have in this formula, as we go across the top, is negative b. So we'd have negative Well, looking at this equation here, what is the value of b? Because b is the term with just x to the first power, yes? So the term in front of x to the first power is positive 3. So we'll have positive 3 here. Plus or minus the square root. Our next term is still b, isn't it? Because we have b squared, so it would be 3 squared minus 4. Our next term is a, yes? What would be the value of a for this here? 1, there's not a term in front of x squared because that's where a is, yes? If there's not a number there, it is 1. And then the last thing on the top of this fraction is c, which is negative 5. All over 2 times a, which is 1. Any questions on how we plugged any of this in? Any questions on how we plugged any of this in? We good with this here so far? All right, y'all ready for step number 3? Simplify. Not that far. We're going to simplify this here. Well, then first we have negative 3. I can drop those parentheses, yes? And the reason I put those parentheses is just in case b is negative, because if it was a negative and negative, it would make it positive. Now, if we wanted to do this by hand, I would do next. The next thing I would do would be b squared, 3 squared, and then see what 4 times, negative 4 times 1 times 5 is. However, everything inside that square root, type it into the calculator. Just type it straight into that yellow calculator. So parentheses 3, parentheses squared, minus 4, parentheses 1, parentheses, and then our negative 5. Just type it in as you see it, as we have written it here. And once you get all that typed in, hit enter. So we will get 29, or you should get 29. You're good? So do we agree with 29? And 2 times 1 is 2. Any questions on how we got to this here? So we mainly are just simplifying things down, yes? Now at this point here, what is the square root of 29? I would do it in the yellow calculator just because I can tell it doesn't look like it will reduce fully. 29 is not a perfect square. This here is the answer, because we can reduce it to a decimal, but unless it asks for approximate answers, it asks for an approximate answer for this here, we can leave it like this here. Now, a big idea of math gives you 2 x's, because I think last night's homework it gave you 2, yes? All we have to do is we have to split this up. The 2 on bottom's not going to change. The square root of 29, negative 3, negative 3. The only thing that's going to be different between these two is the square root of 29 on one is going to be positive, and the other is going to be negative. We have to have both cases. Questions on this here? Do y'all like this here right next? I think graphing is normally your favorite, then this is here, comes in a close second. Yes? But that's all we have to do for this here. That's all we have to do for this here. Questions on this? So looking at this here, what is our first main step? We need to get it equal to 0. How can I do that? We can subtract 10 from both sides. And we do that, 10 minus 10 cancels, and I'm left with 3x squared plus 4x minus 10 is equal to 0. So we have it equal to 0, yes? Now we're going to plug in for a, b, and c, because our formula again is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to have negative b, so that would be negative what? The b term is 4, plus or minus the square root of 4 squared minus 4 times negative 10 all over 2 times a, which is 3. Any questions on any of this here? Any questions on anything we've done so far? Negative 4 plus or minus the square root. And 2 times 3 is 6. Again, I would plug in the calculator. Parentheses around the 4, so 4 squared minus 4 times 3 times negative 10. I think we get 144. Or so 4 squared. 136. I was being hopeful. Right, and now if we type this into the calculator, we get what? Or the square root of 136 would be? Huh? That's too big. Yeah, 2 square root of 34. Okay. I thought y'all were saying 234 was the answer. Okay, 2 square root of 34. That's it. Over 6.
Can I have your attention, please? If there are any
So,
freshman students from Mosley that are interested in doing the education.
okay. Now looking at this here, and again, I have a feeling if you put this answer in the calculator or into Big Ideas Math, or even if you split it up, there's a good chance, I think, they're going to count this wrong. They're going to mark this wrong. Because when we look at this here, when I look at this here, it's probably going to mark this wrong. Looking at this here, is there a greatest common factor between the two numerator terms, our negative 4 and 2, square root of 36? Is there a greatest common factor between them? And we wouldn't look at, Really, I'm looking at the 4 and 2. They have a greatest common factor, don't they? They have a greatest common factor of 2, yes? So what I could do is I can factor it out. I'm not going to factor out the negative, which would leave me with negative 2 plus or minus the square root of 34, yes? And this is over what? Well, what's 2 over 6 the same as? Because 2 over 6 is the same as 1/3, yes? So this here would simplify to negative 2 plus or minus the square root of 34 over 3. But really, it's looking to see, and what I would look at to see if I need to continue on and simplify down, is does this term, and this term Do all three of these spots have a common factor? All three. Do they all three have a common factor? If they do, then we simplify it. If they don't, if this had been 3 square root of 34, well, it's still, let's say 5 square root of 34. Well, 5, 4, and 6 don't all have a common factor, do they? So we would leave it. It's only if all three of these have a greatest common factor between them, then we would simplify it down. Otherwise, we would leave it as is. Questions on this here? We good with this here? Negative inside the square root?
No, that's like negative 2 to the power of negative.
If you can plug in the calculator, it'll do it. On these answers? So let's look at this one here. Let's look at this problem here. X squared minus 6x plus 4. So is everything on the same side of the equal sign?
Yes.
Okay, so we can go on and use the formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have negative b. Well, what is the value of b? So it'd be positive. Because a negative and a negative would make a positive. This is one of the few steps I will skip. I will skip rewriting negative 6 and just write it positive. I don't skip too many steps with using the quadratic formula because there is so much here, so much information here. I don't want to skip too much. The two places I will do the first step in writing it is changing the sign when we plug in b and doing the multiplication of 2a. Those are the two steps I will normally do when I plug everything in. Because changing a sign is not too bad. It's pretty much if it's negative, it's now positive. If it's positive, it's now negative. And that's just in that first spot. And when we come inside, it's b squared, yes? I will still write negative 6 in parentheses squared. I will leave that there. Now the value of a is, and the value of c is, and this is all over 2a. Well, 2 times 1, which is 2. I feel like all of us can do a change of sign and multiplication of 2, yes? We feel comfortable with those two. That's why I normally do those two. It's just easier to do those. Now again, the next thing I would do is simplify what's inside the square root. Sixteen and 36 is 20. 36 minus anybody else get 24? Let's see.
Oh yeah, it's not that one. My bad.
You're good? I want to make sure I got it written down right. Yep. It is 20. Now, we need to take the square root of 20, which is 2 square root of 5, yes? And the yellow calculator will simplify that for us. Now there's a greatest common factor of 2 between all of these, yes? Between 6, 2, and 2, we have a greatest common factor of 2. So I can factor it out of the top, which leaves us with 3 plus or minus the square root of 5 over 2. Well, 2 divided by 2 would give me 1. So it actually just simplifies down to this here. 3 plus or minus the square root of 5 is our answer. Any questions on any of this here? How do we feel about these quadratics? Okay, so looking at this one here, what is our first step? Yes, we need to plus the 7x because we need this equation equal to 0. So we're going to add 7x to both sides. And because there's no like terms, nothing in common, we'll just get 2x squared plus 7x plus 4 is equal to 0. I'm not going to make y'all memorize this formula if you want to write it down, and I would write it down on the review sheet for the test. I would do that. I'm not going to make you memorize this. Okay. Now we need to plug in the values of a, b, and c. So we have negative b. Well, the value of b is, so we have negative 7 plus or minus the square root of times a, which is times 4, all over 2a. Well, a is, what is 2 times 2? So that'll be about the only steps I skip and kind of do all at once. Now we would simplify what's inside here. Can we simplify the square root of 17? No, it's prime. And there are no common factors, so there's our answer. That's it. That's all we have to do for this here. Because we can split it up into 2 separate equations. But that's it. I mean, that's the only thing we can do. All right, we're going to look at the next one here. I'm trying to look and see which one I want to do more. Let's do this one here. We're going to do this one here next. 25x squared minus 8x equals 12x minus 4. What's the first thing we need to do? We need this thing equal to, It doesn't matter what I add or subtract first. What do we want to add or subtract first? Because we can do 12x first. Now this time we do have like terms, 8x and negative 12x. These are the same. And negative 8 minus 12 would be negative 20x equals negative 4. Well, now we would add 4 to both sides. So like I said, it doesn't matter what we did first because we're going to have to do the other one next. So we could have added 4 first and then subtracted 12x second, and we would have still gotten to the same thing. We still would have gotten to the same thing. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Extend the page out just a bit. Any questions on this here before we move on to plugging things in? Any questions on this here before we start plugging things in? We good with this here? Okay, so we have negative b. Well, b is, it'd be positive 20. Because a negative and a negative would make a positive. Plus or minus the square root of negative 20 squared minus 4. Well, the value of a this time is 25. The value of c is all over 2a. Well, we said a was 25, yes? What is 25 times 2? 50. Now, if you want to or need to write out 2 times 25 first and then simplify it, do it. Because if you need this to be set up as negative 20 plus or minus the square root of negative 20 minus 4 times 25 times 4 all over 2 times 25, and then go to this here, that's fine. There's nothing wrong with that. There's nothing wrong with doing that. Okay? There's nothing wrong with doing that in-between step. And if you need that in-between step, do it. Do that in-between step. Because if it helps, do it. Now at this point here, we could plug everything that's inside the square root into the calculator. Negative 20 squared minus 4 times 25 times 4 gives us 0. Well, what's the square root of 0? Does adding or subtracting 0 change anything? No. So we really just get 20 over 50 because adding or subtracting 0 doesn't do anything, so we can just drop it. Can I reduce 20 over 50? And we get this here. Questions on this here? Questions on this problem here? If we're good with this here, so we only got one answer. So far we've been getting 2, now we got 1. Let's look at this one here. So again, what do we need to do? We need to get equal to 0. So how can I do that? We could minus 13 from both sides. And even though x squared is negative, that is fine. It doesn't matter for us here. Because we really just want it equal to 0. Any questions on how we got to this point here? Any questions on any of this here so far? We good with all this here? Yes? So negative b is first. Well, we'd have negative plus or minus the square root of 4 squared minus 4 times negative 13 all over 2 times negative 1, which is going to be negative 2. Negative 2. Okay. All right, let's simplify what's inside the square root first. So 4 squared minus 4 times negative 1 times negative 13. Negative 36. So probably at this point here, you've been wondering why I said at the beginning we don't type the square root in first when we simplify what's inside the radical. Yes, it's negative 2. Thank you. Because will the yellow calculator, the TI-30XS, take the square root of negative 36? No, it doesn't do imaginary solutions. It doesn't work with those. So that's why I don't normally take the square root of 4 squared minus 4 times negative 1 times negative 13 for this one here. I don't use the square root. Because if I'm using that yellow calculator, I know it will not simplify it all the way. It'll just throw it out as domain error. But what do we know about the negative inside of a square root? It always comes out as pi. So I pull it out. So if I pull that out, what am I left with? The square root of 36, yes? Well, the yellow calculator will do that now, won't it? It'll simplify radicals as long as the number inside is positive. So we get 6i. Is there a greatest common factor? 2, yes? So if I factor it out, I'm left with negative 2 plus or minus what? 3i over negative 2. Any questions on how we did this here? Any questions on any of this here? We good with this here? Well, 2 over 2 would simplify 2. Negative 1, yes? But we still have a negative that's going to be out front because the 2 in the denominator was negative, yes? All right, I'm about to blow someone's mind. Well, negative and negative make a. So we have 2 plus or minus 3i. Is anybody's brain a little with how that worked out? I mean, the 2, we're good with this, but anybody a little questioned on the plus or minus? Let me break it up. I'm going to do this again. Negative 2, because we have negative 2 plus 3i, and negative 2, about right plus again, minus 3i. Yes, these are our 2 statements for that plus or minus. So when I multiply it through, well, the negative and negative make a positive, yes? Negative and a positive make a negative. So we're good with that there, yes? Negative and a negative make a negative and negative make a. So when I put these back together, I get 2 plus or minus 3i. Because that plus or minus, the positive became the negative and the negative became the positive. So the plus or minus essentially flipped, but it ended up being the same thing. Questions on this here? Questions on this here? Now looking at this here, there are 3 solutions we could get. I could either have 2 real solutions, they could be irrational, but they're 2 real, 1 real, or 2 imaginary. Those are the three setups that we can have. Is that I could have two real solutions, one real solution, or two complex solutions. Because we saw that today, didn't we? Because the first so many we did and were two real solutions. They were irrational. They had the square roots, but they were real solutions. Would y'all agree with that? Then we came across not the one we just did, but the one before that. We had one solution, our 2/5. And this last one that we did, we had two complex. We had I. So these are the three cases that we can have. Now, what's interesting is that if b squared minus 4ac is greater than 0, we have two real solutions. And this is called the discriminant. The discriminant is that part inside the square root. So if b squared minus 4ac is greater than 0, we have two real solutions. Now, what happened to b squared minus 4ac when we only had one? What was this equal to? 0. Because when it was 0 on that one where we got 2/5, it simplified out, didn't it? We will only have one. Do you have a guess at what complex is going to be? B squared minus 4ac is going to be what? Less than 0, because if it's less than 0, it's a negative number, and if we take the square root of a negative number, we get our imaginary terms. Questions on this here? Find the discriminant of the quadratic equation and describe the number and types of solutions of the equation. So looking at A, we have x squared minus 6x plus 10. Well, the discriminant is what? B squared minus 4ac. Yes? That's the discriminant. That's what's inside the square root. So if I want to see, kind of describe the types and numbers, well, what's the value of b for this equation here? So negative 6 squared minus 4. A is 1. C is, type that in a calculator. Yes. Uh, 36. Yep, negative 4. Y'all agree with this here? So since the discriminant is negative 4, we have two what? Two complex solutions, because b squared minus 4ac is less than 0. Because again, our complex conjugates theorem stated that if a plus bi is a solution, a minus bi is also a solution. They can never go by themselves. Because if only one of them did exist, these quadratics would have I terms in them. Because the only way that I simplifies out to numbers is if its conjugate is also there. Questions on this here? Questions on this here? Now, most likely the homework is going to ask for this to be solved. So using x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, negative b in our case would be negative 6, which would be 6 plus or minus. I'm going to worry about the square root here in a second. But 2a would be 2 times 1, which is 2, yes? I don't have to do b squared minus 4ac for this one. I don't have to plug it in. Because what is b squared minus 4ac for this problem? We already found it. Because doing this here pretty much told me what it was. Well, this here, well, the negative would come out as, and the square root of 4 is 2. Now, all three of these have a greatest common factor of 2. I can just divide it, yes? 6 divided by 2 would be? Because I'd have to do both of them, because 6 divided by 2 is 3, 2 divided by 2 would be 1. We have to do both. And so the answer for this here is 3 plus or minus I. So if it does ask for it, because most likely I know it's going to ask for negative 4, 2 complex, it might ask for what the actual solutions are. We'd give them here. Any questions on this here? Do we need to see another example of one of these? We're good with these here? So I would make sure that you have the breakdown of what b squared minus 4ac, if it's greater than 0, less than 0, equal to 0, how that relates to the number of solutions. And that would be it for today.